minutes. Now I've already pissed away 15 minutes messing around getting it working, so it'll be starting in 25 minutes time. We'll be doing another one. Okay. Now, so we said a queue. So this is a collection. So array deck is the one we're going to do. Okay. So array deck implements collection, queue, deck, and iterable. The main thing about an array deck is that it's a queue. All right. So what's a queue? A queue, as I said before, it's something that's like this. There is 4 people queuing to go into a shop. Okay, and where do you add to a queue? You add to the end of a queue. In exceptional circumstances, you can add to the beginning of the queue. Let's say if someone is sick and they want to get in there, or someone is old. Okay, if you have a 90-year-old man, you don't want a 90-year-old man going at the back of the queue. So what do? You put him in the front of the queue. All right. So normally you go at the back of the queue. So you insert something, goes in the back of the queue. Okay. Now you can't insert in the middle of the queue. Okay. And in exceptional circumstances, you can insert in the front of the queue. So that's what the way array decks operate in real life as well. Okay. Now, so you can add to the queue. Okay. Now, when you add to the queue, it adds to the end of the queue. So as we can see here, we have our queue initially consists of hello, apple, orange, banana. Duplicates are allowed in an array deck in a queue. So hello, apple, orange, banana. Now you can add, if I add tomato to it, what happens is it adds it to the end of the queue. Okay. Now the first difference between this and a list, this does not implement the list interface. Okay. You can't add null. That's the first major difference. The second major difference, as I've already said about a queue, you can't insert in a particular location in the array deck. Okay, so you can't go add 3 pineapple, for instance. That will not work. Okay. Yeah, so I'm going to go down the screen. So I print it off and we can see that I have got hello, apple, orange, banana, tomato. Okay, now, so we have push. Now push, what does push do? So we have our queue here. Right, that's the end of the queue. The beginning of the queue. Now what push does is that it puts an element at the start of the queue. Okay, so what does it do? It puts turn up here. Now if I'd said add, it would put it to the end of the array deck. But when you push something, it pushes it to the beginning of it. All right, so turn up goes in here, and we can see we have it there. Turn up hello, apple, orange, banana, tomato. Yes, that's all push does. Push is nothing more fanciful than that. Now, you might ask yourself, well, why would I want to use these instead of an array list? All right, anywhere you're going to be adding things to the top of a list. All right, so if you have, let's say you're trying to represent a box. All right, this is your thing at the bottom. So this will be, what's at the bottom? What's at the bottom is the tomato. See here? What's at the bottom is the tomato. And what's at the top is turnip. Okay? So if you have a need for a queue, if you want to represent a queue, all right, let's say you have a load of items wait to be checked out of a checkout. Okay? If you have a load of items waiting to be checked out of a checkout in a supermarket, you could use a queue. All right? So what are you doing? Every time you add something to it, every time you push something to your queue, you're putting it to the end of the queue. or sorry, at the beginning of the queue. Okay, so each new item that's added to it, each new item that's pushed to it, it's pushed to the beginning of the queue. And as you're checking stuff out, as they're being put through the scanner, they're going out here. Now the other way, so you push and you pop. It's called the other way. Okay, I think it's pop, isn't it? Huh? Yeah, pop. Pop removes at the end. Push adds at the beginning. Okay, so think of when you're checking something out. All right. By the way, you do realize that when you're checking something in a, so let's say Tesco, you know the scanner, the beep, every item is unique. Do you know that? Every barcode is unique. So what I mean by that is the barcode is, so let's say it's going to be a can of beans, right? Heinz beans. And as far as I know, each can of Heinz beans is unique. It each has its own unique identifier. Do you understand that? Okay. So a queue will work in a supermarket because every item in the supermarket is going to be unique. All right. So you're going to, someone scans in a can of beans, another can of beans, a loaf of bread, a litre of milk. So they're all scanned in, and then we pay for them. And as we pay for them, they're taken out of the queue. Okay. Is everyone okay with that? Yeah. So that is pushing. So pushing, what does it do? It pushes it to the start of the queue. So our array deck, first element was hello. When I push turn up to it, we now see turn up here at the very beginning. Yes? Previously, when we added tomato, it went to the end. All right? Now, these are not lists. So I can't add turn up to the middle of the array deck. Just doesn't work that way. Okay? So, as I said down here, push operates like a real queue. Okay? Well, the 16 entries is, that's the initial size of the array list. Initial size? No, I don't think it does, Kieran. It can't. No, it doesn't. It doesn't have a, no, it doesn't. Um, no, it doesn't. It doesn't, as far as I know. Okay. So it doesn't have an initial size. Now, as you can see, add, what add does, add puts it to the end of the list. Kumquat. Okay, so push puts it to the start of the list. Add is going to put it to the end of the list. Yes? Okay, now, so the other commands of it. So give me a second, let me show this all here. So offer. Now offer does the same thing as add. Okay, offer does the same thing as add. It puts it to the end of the queue. But to prove that it does, now also offer returns a boolean. Okay, push doesn't, returns void, so you can't put in a print statement. However, offer does return a boolean. If it's inserted, it'll return true. If it's not inserted, it'll return false. Okay, so we should see caret appearing at the end of our list, our array deck. You can see caret at the end. Okay, offer, so I'll put it in here. Offer is the same as add, and the string caret is added to the end of the array deck. Now, can you see me type? And does it keep up with my typing? Does it? Okay, that's good. Is that big enough? Will I make the text bigger or smaller, or is it okay? Is it okay? Okay. Right. Now, so offer, what does offer do? Offer adds it to the end of the list. Okay. Push adds it to the start of the list. Okay. Push just returns nothing. Okay. So yes, offer returns a boolean. True if inserted. False if not. For instance, if it's a null, if it's a null object, it'll return false. Okay. Even prove it. If I go dot offer null, it gives me null pointer exception. Okay. Right. So won't insert it. Just take that out. Okay, so carrots at the end. Okay. Now, so that's our list. That's what our list looks like now. All right. So our list consists, our array deck consists of turnip, hello, apple, orange, banana, tomato, kumquat, carrot. Okay, that's what it looks like now. All right. Now, so the next thing we're going to do is pop. Now, what does pop do? Pop removes first element from the list. Okay, and returns that element. Okay, I'll show you what I mean. Okay, so I'm going to go str, so I'm going to print it out. Str deck dot pop. Okay, so what does that return? That returns turnip. All right, so it returns the first element in our array deck. First element in our array deck is a turnip. Now at the same time, it removes turnip from the array deck. So if I print it out, show what I mean. So strdeque, we can see the turnip is gone. All right. So pop, what does pop do? Pop removes it from, so we have all our letters. Okay, so we have turnip, hello, apple, and the last one is carrot. So what does pop do? Now pop, first of all, it returns the actual object. Okay, returns the actual object, then it removes it from the array deck. Okay, so it returns the object turnip, then it removes it from the array deck. So you can see that str, or the array deck str deck, no longer has a turnip in it. Okay, so put it in here. Turnip is removed from the array deck str deck. Okay. Now, if you have an empty array deck and you try to pop something from it, so I'm going to quickly create a empty array deck. So I'm going to go, let me see here, deck, array deck, string, so I'll call it empty deck is equal to new array deck. Okay, so this is an empty array deck. So if we attempt to pop from an empty array deck, that's what happens. So empty deck dot pop, get no such element. Can't remove something that's not there. Okay, so that gives us a no such element exception. Okay, if you try to pop from a empty deck, you will get a no such element exception, which is a runtime exception. Oops. Which is a runtime exception. Now, if I'm trying to remove from an empty deck, actually I'll do poll first. So that's pop. Okay. Now, you can also, I know this shit is boring, but we have to cover it. You can poll. A poll does the same thing as pop. Why they have the two of them, I don't know. Okay. Now, so what does poll do? Poll does the same as popping. And removes the first element and returns that element. Okay, so if I go str deck dot poll, okay, now poll, our list now contains hello apple orange banana tomato kumquat carrot. Okay, so what this do, this will print out hello. So this will print out string hello and then remove it from the str deck array deck. So that'll remove it, and then we can see it removed. Okay, now hello has gone from it. Now, as well as poll, we can poll also last. This one, poll last. Now, what's poll last? It's exactly the same as poll, except at the other end. What does this do? This removes the last item. Sorry, this returns the last item in the deck and then removes it from the deck. Okay, so this should be displaying carrot. So we poll last. Okay, this should be displaying carrot and also removing it from the end of our deck. So STRDEQUE. So running out of time. We've removed the 40-minute. Oh God. We've removed the 40-minute time limit on your group meeting. Thanks very much. So we can keep on going. Love it. Thanks very much. Very good to you. All right. So that removes the last thing. Okay. So this removes caret. This displays the string caret. Okay. We can now see caret is removed from the deck. No, there's a pole first. Now, I don't know what the difference between pole first and pole is because they both do the same thing. There probably is some difference. Let me just see what it is. STRDEQUE. No, it doesn't. Hold on. I just want to see. I'll just have a look first. PO. So we have pole first. We have pole last. Now the thing is, pole and pole first do the exact same thing. So what's the difference? I don't know the difference. Is there some difference? Yeah, yeah. Well, no. Pole is about removing stuff. Okay. Popping is about adding. Okay. Which actually doesn't make sense to me, but oh no, pop. Sorry, you're right here. Sorry. I'm talking to me arse. Okay. So push adds. Popping removes. Yeah. So pop removes, for instance here, turnip is our first thing, so removes it. Now, polling does the same thing. Poll last removes the last one. Okay? But it displays it and removes it. Okay? Now, popping does the same thing. There's also a poll first, which is the same as poll. Okay, so I'll just put it in here. As far as I can see, there is also a poll first, which, as far as I know, is the same. Yeah. Now, the only thing with these is you can get a small bit confused. I get confused. So push means you're pushing someone into the queue. Popping, getting rid of. Polling, getting rid of. Poll first is the same as polling. Poll last, you get rid of the last on the queue. In exam situations, it's very easy to get those mixed up. Okay? And that you are going to be given questions in the exam that know you're going to get mixed up. All right? So, pushing, you're adding to the queue. Popping means you're removing the first element, which is the same as poll, removes the first element, which is the same as poll first. Poll last then displays the element or returns the element and then removes it from the deck. Is that the difference? Okay. Say that again now, Jason. Okay, all right, so that is the difference. So pop. So I want to I want to get that. So if it returns an exception, if what? Oh yes, so, yeah, yeah. So if you pop, this will give you a runtime exception. So polling. So we have an empty. This is our empty deck. Okay. So if I go, it'll just return null, isn't it? Empty deck dot poll. emtyd q. So this should return null. And it does. Okay, so the difference between popping and polling, it's Jason, between popping and poll is pop returns a no such element exception. No such element exception. And poll, so if used on a empty array deck, and poll returns null if used on empty array deck. Okay, so that's the difference. So that, Jason. Now, you can also poll last. That'll remove from the last. So we have apple, orange, banana, tomato, kumquat, carrot. So poll last will remove carrot. Okay. Now you can imagine a situation, which I think I have done here. Well, I'll do a couple more. Now remove. So remove with the list, remove the last element. Yes? Remember that? If you have a list of something, 1, 2, 3, 4. If I would call remove on a list, you're removing it by its position or by its value. Yes? Remember that? Now, when you use remove with the queue, it doesn't give you the option of removing it by position. Okay? So, put it in here. So, now, don't be thinking we're just doing these for, because they're something obscure and they're used in only exams. They're not obscure, right? They do have very real usages. Anything that's going to be operating on a queue in real life, use these guys. That's what they're for. If you want to do any sort of processing with them and you want to insert them into a list and do that sort of thing, it's easy enough to convert from a list to a queue. Okay? There's nothing dramatically complicated about it. I will show you how to do it. There's nothing to it actually. All right? So anything that operates in a queue, there's a lot of things that operate in queue. Think about a factory. Everything works in queues. Software development works on queues. Okay? So anything that works in queues, you could use these guys. Now, if you don't want to, if you want to use lists, then that's fine. All right? But these are just another tool. They're another type of list. All right? So remove. What does remove do? So I'm going to, we have our array deck now. It has apple, orange, banana, tomato, kumquat. Okay? So if I go str dot remove, now, as far as I know, this does display it. Let me just see. So this displays the text that's going to be removed. Okay? And then it is removed. So just like poll, and just like pop, okay? Just like poll and pop, it removes the first item from the list. Okay? So just like poll, just like pop, it removes the first item from the list. which is, so first thing it done, just like poll, just like pop, sorry, it returns first element in the list and then removes it from the array deck. Okay, so this will display string apple. Apple is removed from deck. You can see it's gone there. Is that okay? Now, like push, if you try to remove from an empty array deck, you're going to get a no such element exception. All right, so we have empty deck dot remove. Empty deck dot remove. That gives us a no such element exception. Okay, so if you use remove on a empty array deck, if you use remove on an empty array deck, you will get a no such element exception like push. Okay, so not push, yeah, push, yeah, sorry. Like pop, sorry, fucking hell, sorry, I'm getting mixed up now myself. Okay, so push adds it, pop takes away the first element from your list, poll removes the first element from your list, poll last removes the last element from your list, and both of those return null. Remove removes from the first element of your list, and just like pop, it will generate a no such element exception you're trying to remove from an empty array deck. I don't know if I covered this before. If you're trying to remove something, if you're trying to remove from an empty list, you're also going to get a no such element exception as well. Okay, so comment out that guy. Now, so let's just say we want to get a look at our array list or at our deck. Okay, we want to see what element is going to be removed. Okay, so what we can do is we can go strdeque dot print it out. So I'm going to go strdeck dot peak. Now, what does peak allow us to do? Peak allows us to see the first element in our list. So the first element, now it doesn't remove it. Okay, so what does peak do? So put it in here. Peak. So allows us to see the first element. Just to prove that it does, it should be just printing off orange. Okay, so what does this do? This allows us to see the first element and does not delete the string from the array deck. Okay, to prove that it's still the same, before peak it's orange apple, orange banana, tomato, kumquat. After it, it's still orange apple, orange banana, tomato, kumquat. So push, pull, and remove, they all remove it. Okay, all peek does is just displays it. All right, so let's peek's the first element. You also can peek at the last element. So we have peek last, which will display the last element. Okay, and we can also, there's also peek first. Now, what's the difference in peek and peek first? I don't know. As far as I can see, there isn't any. Now, so how could we use this particular thing that we've done here? Okay, I'm going to create a list of numbers. And I'm going to add to that. Arrays as list. I'm going to put in a load of, so 20, 456, 3056, 1, 2, 3, 20, 99, 100, 300. Okay. Now, I'm going to create an array deck. So I'm going to say array deck. Integer. I'm going to call it deck numbers is equal to new array deck. Now I'm going to make a copy, so you can do this. Now, it's a quick way of, now that's, that is an array deck reference to this list. Okay. I asked this question, it's a quick question. Right. So this is going to be a array deck created from this list of numbers. Okay. You can also create a list from an array deck. So what we're doing here is you create an array deck. So it has a constructor. All right. It has a constructor. Now this applies for queues. This applies for lists. And this applies for sets. Okay. You can create a queue by passing in a set, a queue, or a list. Okay, you can create a list by passing in a list, a set, or a queue. All right, so you can create a, right, so here, we just call this, this is a deck, which is a queue, right? You can create a queue by passing in a list. I'll do all the different types. Okay, I'll do all the different types. So that's a list. I'm going to do set. I won't do a set yet. Right, so you can create a queue, okay, by passing in a list, a set, or a queue to constructor of the queue. Okay, you can create a list by passing in a list, a queue, or a set. List. You can create a set by passing in a list, a queue, or a set to the constructor. All right, so you can see here I have created a queue from a list. I can also do, I create a set. And I'm going to say set numbers is equal to new hash set. Now we haven't done hash set yet. I'm going to pass it in numbers. Okay, so you can see there I've created a hash set from a list. I can create a list from an existing set of numbers. Okay, so all of those, so array deck, that's a queue. So we're creating a queue from a list. Set, integer, hash set, that's going to be one of the types of sets we're going to be using. We are creating a set from a list of numbers. Then we have a list. We're creating a list from a list of numbers. And all of those interchangeable. Okay? Because what goes in there, it's something that has to implement the collection interface. Okay? So the constructors for all sets, queues. Queue is a superclass of deck, which is a superclass of array deck. So the constructors for all sets, queues, and lists can take a list, set, or queue. Here we create an array deck from an existing list called numbers. Here we create a set of integers from an existing list called numbers. And here we create a list of integers from an existing list called numbers. Okay, so the constructor can take any object that implements the constructors for all queues, the constructor for all sets, the constructor for all lists and all their subclasses can take any object that implements the collection interface. Okay, any set, list, queue, and subclasses can take a object that implements the collection interface. Okay, so what can you put in here? You can put in a queue, you can put in a linked list, you can put in a tree list, you can put in what other types do I have? Hash set, a set, a linked tree hash set, which we're going to be doing. Oh God. All right. Now, one thing that these cannot take is a map. All right. So you could say queues, sets, and lists, they're all interchangeable with one another. They're relatively easy to convert from one to the other. Maps are different, okay? Because maps do not implement the collection interface. All queues implement the collection interface. All sets implement the collection interface. All lists implement the collection interface. Any questions on that? Is that understandable? Okay. So it's, you can see here, let's say you have a list done out. and you want to put it into something called a tree set. Now a tree set is going to organize all your elements in the correct order. All right. So you could put in a list, which is something called an unordered list. The tree set then, it'll put them all into the tree set, but it'll put them in an ordered fashion. All right. So it's relatively easy. Also, another thing it does, let's say here we have an array deck. All right. Array deck numbers. Let's say I put in sets here. Okay. Set integer set numbers hash set. Right. I'm going to display set numbers. Now we haven't done these yet, but I'll just briefly show you. Okay, so I print off set numbers. Right. Look at this list. And look what happens to it when I put it into a set. Do you notice any difference? What's the difference? The order is different. Yeah, there's a reason for that, but what's the main difference there? Yeah, why? One number's been left out. It's either the first one or the fifth one, because they're duplicates. Hash set removes duplicates. So one very easy way, if you have a list and you want to remove duplicates from a list, what do? You create a hash set from the list. They're all gone. If you create something called a tree set, I think it's tree set. Now, hold on a second. So let me show you this one. I think it's tree set. So tree set, integer, and tree numbers. I think that's the right spelling of it. All right, so tree set tree numbers is equal to new tree set. So I'm going to create tree set from numbers. All right, so I'll print off this guy. So I created a tree set from numbers. So tree numbers. See what that's done? Tree set puts them in order. So tree set does two things. It removes duplicates and it puts them in order. So do you remember? I remember before in Java 1, to those that haven't done Java 1, I gave you something before about trying to organize numbers in a list. That does it all for you. Okay? So it's relatively easy to convert from one collection type to another collection type. All right? So this one here, this will remove the duplicate number 20. This one here, this will remove the duplicate entry 20 and also arrange your values in ascending order. Okay, now tree sets are tricky enough because they only work with something called the comparable interface. But with numbers, what tree set does automatically is organize them for you. All right, so it's relatively easy to organize numbers in a list. All you have to do is just throw them into a tree set and they're organized for you. Yeah, or you can put them into a database and let them look after it for you. Remember those? Select all from whatever. I can't fucking remember it. Right? Whatever. Okay. So it's relatively easy to convert from one list from one collection type to another collection type, right? All you have to do is just put them in the constructor. Works like that, okay? Okay. So we have an array deck of numbers. It's called deck numbers, okay? So here's a practical example of how to use. So deck number contains all of these numbers, and it does contain 20, okay? So it contains all these numbers. So I'll just so it contains the numbers. What numbers it contain? It contains 20. So it contains the numbers 20, 456, P456, 1, 2, 3, 20, 99, 100, and 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8. 8 numbers. Okay. Now, let's say we want to add up the numbers, but at the same time as adding them up, we want to take them away from the list. All right. So you can imagine a situation, you're trying to count all the money you're taking in, so putting it aside. So you're taking it from one bundle, right? And as you're taking it from the bundle, you want to get the amount of money that's in it. All right. So here we're going to use a queue. Now, I already have this guy here, deck numbers. So you can do this. So while now, so I go deck numbers. Is that it? Yep. So while deck numbers that is empty. So what I'm going to say is while it's not empty. Okay. So what am I saying there? While it's not empty. Okay. So what I'm going to do is I'm going to go sum is equal to, oh, I didn't say what sum is. Int sum is equal to 0. So while the array deck is not empty, I'm going to go sum is equal to sum plus deck numbers dot poll. Why am I going? Try that again. While and I go deck numbers that is empty. That guy there. That guy there. Next line, then I go sum is equal to sum plus deck numbers dot poll. So what that's going to do is it's going to add 20 onto 0. Then it removes it from the array deck. It's going to add 456 onto 20. Then it removes it from the array deck. It's going to add 3,456 to whatever we got the total was here. And then it removes from the array deck. It's going to add 123 to whatever we got here and removes from the array deck. It's going to add 20 to whatever we got here and removes from the array deck. it's going to add 99 to whatever we got up here and remove it from the array deck. It's going to add 100 to whatever we got for these lads and remove it from the array deck. It's going to add 3,456,789 million to this list or this array deck and remove it from the array deck. So you end up with an empty array deck. Okay, so you can be keeping a running total of the stock that's going in and out of your stock room. Okay, so you can see if I take out 1,000 cans of beans and each one of those cans of beans are 50 cents each, you now have, and they're in stock, so you get 500 quid's worth of stock. If I take 250 out of those out, right, if I have 1,000 cans of beans that are euro each, okay, as they've been taken out, I can see how much has been taken out. 500 taken out, there's 500 euros being taken out, that's 500 by 1. Okay, so this is a practical example now just to show you that it is working. So it should give us the sum. So at the end of it, the sum is plus sum, which is a big number, okay, and deck numbers is empty. Okay, so you can empty a queue and be adding up because you're emptying the queue. You can also be populating the queue and you can be adding to it. Okay, any questions on that? No? Okay, so I'll just put in a comment here. While our array deck is not empty. Now, is empty returns true or false? So add a number to our sum and then remove it from the array deck numbers. You see, this is the thing. You can use for each, yeah, for each will work with, but you can't get the number. You can't get a number to position in a queue because that's not what they're for. If you want to get the number of where something is in a queue, you'll convert it back to a list, right? To add them all up for each, for each, for each, for each, for each of these. Okay. You can't do it with the traditional while loop because I can't. For instance, we have our queue here, and it's got, let's say, beans, milk, bread, and butter. All right. A queue is not about positions. A queue is all about adding stuff at the beginning and taking away stuff at the end. That's what a queue is for. A queue is not to determining what's in between. So how do you find out what's in between beans and butter? You can't use a queue is the answer. As far as I know, let me just have a check. I don't think there's any method in the queues. So let me just see. You can use contains, which tells you if it contains it or not. Oh yeah, you could use an iterator actually. All right, you could use an iterator actually. Yeah, you could. Right, so sorry, I stand corrected. Or hold on. B C D F G. No, iterator doesn't work either. All right. Oh, it has a descending iterator. Okay, yeah. It doesn't have list iterator though, does it? No, it doesn't have list iterator. Okay. So this way though, it's just change it to a list and add them that way. Okay. If you want to find out where you just bung them into a list, because best way to describe it, a queue, it's all about determining what's happening at the start of a list and at the end of a list. It's not really too concerned about what's in the middle of the list. All right, that's what a queue is really for. So it's for here and here. And as you said, Andrew, you could use the descending iterator to find each element in it. That's not really a queue is for. A queue is all about what's happening at the end and what's happening at the beginning. Okay. And if you want to add them all up, the easiest way is through a for each. It's actually very easy when you get used to using for eaches. Okay. So the easiest way probably would be to add up all the numbers is to use for each. Any questions on that? Okay. Now, as well as having an array deck of strings, you can also have an array deck of any objects. So I'll just quickly do this. I'm going to copy it. This is an array deck of dogs. So array deck dog kennel, new deck. So list dog, dog list array, arrays as list, new dog spot, new dog Rex, new dog Lassie, so on and so forth. So you can also do add all with this. So I go kennel dot add all, and it can take any collection dog list. Okay, so that's another way to do a copy. All right, that's another way to do a copy. So, and they're going to be the same list. And kennel. Now, so Kieran, you can see there. Now, this is probably a bit messy, but it's relatively easy to copy from a list to an array deck. So if you want to see where something is in a position in an array deck, you can use a list if you want to. You can either go kennel.addAll, or when you're creating your array decks of dogs, you just say array deck dog kennel is equal to new array deck, and you put the dog list inside. I'll show what I mean by that. You could also do this. So I could say kennel is equal to new array deck, and I can put in dog list. You can do that also. Okay, they're all copies of the list. Now you can ask the question, are each one of the animals a copy of the animals, or the same animal? Do you understand what I'm saying? Is the dog, this dog in this list, the same as the dog in this queue? Yes? The answer is, well, for certain, are the different lists. So if I go SYSO, if I go kennel dot equals dog list, now that should return false. It can't be the same thing, because one of them is a queue and one of them is a list. All right, so they couldn't be the same. Yes. Okay. Now, so the last dog in our kennel, so SYSO, this is kennel.peak last. And peak doesn't remove it, yeah? The kennel.pink last is Lassie, yes? And the last dog in our dog list, so dog list dot get, so we have 1, 2, 3, 4. So it's get at index position 3. Right, so name of Lassie, age is 10, name of Lassie, age is 10, right? So the question has to be asked. These are the questions now you are going to be coming up with. We do want to go into this in more detail in the next section, which we're doing compare and comparable. It's comparable and the comparator. All right. So these two dogs, are they the same dog, or is it a dog with the same name and same age? All right. So how do you find out? It is kennel dot pclass dot equals dog list dot get index 3. Now, this is where it starts getting really tricky. All right. Here's the thing. They're yeah, right. So they're different collection objects, but they contain the same dogs. All right. There are different ways of looking at a collection of dogs. An array deck okay, so now, so it has all these dogs. So both the array deck and the list both have those dogs. All right. So the collections are different, but the dogs themselves are the same. Think of them, you're looking at a collection of dogs in a different way. All right. One is looking at them through the prism of sex. Another one is looking at the prism, what I mean by sex, you'd have a dominant male, and then you'd have all the females in the pack. Okay. Another way of looking at it is by age. So you'd have one dog that's senior, and he'd have higher privileges than all the younger dogs. But they're all the same dog. Okay. Now, does this make much difference? Kind of does. Really. This is all about calling shallow copying and deep copying. Now, here's the slight contradiction. I think this is a contradiction in terms, but that's neither here nor there. Now, a shallow copy is a copy of everything, right? This is a shallow copy. Dog spot is equal to new dog. Dog Rex is equal to spot. That's a shallow copy. Spot and Rex are the same dog. Okay. A deep copy is where you're just copying the values. Okay. So, for example, for Lassie, a deep copy of Lassie would be two dogs, two different dogs, one called Lassie. So, two dogs, two different dogs. They're both called Lassie. They both have an age of 10, but they're different dogs. That's what a deep copy is. All right. So, yes, using all these ways is very handy for creating copies of your list. But it's a copy of the list. You're still using the same objects. So if you've got 3 dogs in a list, you copy those 3 dogs into a set. It's still referring to the 3. So it's a different collection, but it's still the same 3 dogs. which can cause real issues if you think about it. If you're trying to create a copy of a dog rather than a real dog, instead of having two dogs, you might only have one dog. You think you've got 5 different sorts of lists. So you've 2 dogs in each list. You think you've got 10 dogs. You don't. You've only got 2 dogs. You have a hash set of 2 dogs, which is based on a list of 2 dogs, which is based on a queue of 2 dogs. So you have you have a set, you have a list, and you have a queue. There's only 2 dogs in those. All right, that is a shallow copy. Now, shallow copy is what's done automatically in Java. Deep copying, here's the thing, there isn't really a method that deep copies for you. There is something called clone, but that's not exactly what you want to do. It's different to C++ and C#. There is methods in that will do a deep copy for you. There isn't really any such thing as a deep copy method in Java. So you usually have to create one yourself in your classes. You have Right, so you disappear. Right. I create a list of dogs. And the 3 dogs are a dog with no age, an age of 0, and a name of null. A dog with a name of Spot and an age of 3. A dog with a name of Rex and an age of 5. A dog with a name of Lassie and an age of 10. Okay? And we'll say this dog lives in Galway. Second dog lives in Dublin. Third dog lives in Belfast. And the fourth dog lives in Cork. Okay? Then I come along and go kennel.add all dog list. Okay? Now what you're doing there is that you're copying the references. Okay? So the first dog in the kennel is this dog. The second dog in the kennel is this dog. The third dog in the kennel is the dog from Belfast. The fourth dog in the kennel is the same dog from Cork. Okay? It's not that they're different dogs, it's a different list of the same dogs. Actually, I think we did something like this in Java 1. We were talking about it before. So that was with just lists. This is the same rule that applies across all collection objects. Okay, now to prove it, so kennel.pclass equals doglist.get3, which is that dog. Okay, so I'm asking, are they the same? Hold on a second. Give me a second. I just want to get rid of these guys. I'm getting rid of the hash code in the equals method. A second now. I'm still hopeful that this is still the same. Yeah. Okay, that's fine. All right. So the equals method of the hash code doesn't really matter here. Okay. All that matters is that this guy here, this is a shallow copy. When you create a list from another list, it shallow copies them. It doesn't deep copy them. It copies the references. So it copies the dog from Galway, Dublin, Belfast, and Cork. I'm going to create a set No, I won't create a set. I can't create a set. So I'm going to create a new deck. And my dog. We're going to call it kennel 2 is equal to new array deck. And we're going to create it from the existing list of dogs called dog list. Oops. Lowercase d. Now, if I go, is kennel 2 same now, let's see. So is it the same as dog list? It's going to say false. Okay, different lists. Yes, everyone with me so far? Yeah. So this is creating an array deck from a dog list. Now we're saying, are they same? Kennel 2 equals dog list? No. Okay. However, if you print them out, why is that giving me a fucking error? Lowercase k. Fuck's sake, no. And I print off dog list. So we can see they've got the same elements inside them. Okay. Now alone have the same elements inside them. So I can see that this dog has the same name and the same age. So these two dogs, the last dogs on both of them, both have got the same age and same name. All right. So if I go, so kennel 2 dot peak last that equals dog list dot get 3. Same dogs. Okay. So they're different lists that have got the same dogs. All right. They're different collection objects that have got the same objects inside them. All right. So that all goes to show these are all shallow copies. It's only the reference that is copied. Okay, so they're not the same list, not the same collection object, but contain the same dogs. All right, so you need to be careful with that. All right, so what you usually do, if you want to make sure, if you want to copy a copy of the dog, all right, you'd need a method in the dog class that creates a deep copy for you. All right, there is no real method in Java that will do a deep copy for you. You usually have to do it yourself. Now there is something called clone, but it doesn't exactly do what it's supposed to do. Now clone is not on the exam, but I am going to cover it in the next section. Is that okay, everyone? Because you need to be able to get around this problem. It's not a problem. It's just that if you have a hash set based on a list of dogs, if you have a tree set based on the same list of dogs, if you have an array deck based on the same list of dogs, doesn't matter what collection type it is, it's still the same dogs. A list of 3 dogs. You create an array deck from that list of dogs. You create a hash set from that list of dogs. You create a tree set from that list of dogs. You create a linked list from that list of dogs. There's still be only the 3 dogs. There isn't copies of the dog made. It's still the same dogs. Yep. Yep. They will. Yeah, because they're the same dog. So the rule that we had for lists, remember when I said about we did do this in lists, it's the exact same list rule across all collection objects. Okay? It's relatively easy to make a shallow copy. It's a lot more difficult to make a deep copy. And we're going to do deep copying in the next section. It's all this shit I was doing. Okay? We are going to do something called the clone method. Now, it doesn't really work the way it's supposed to work, so you always have to override it. You always have to do something with it. Is that okay? So we're going to be using the clone method to create deep copies. Okay? So shallow copies, it's what's done normally. Now, why would you want to create, let's say we have 3 dogs, right? And this is a list. From this list, we want to create a hash set of dogs. We want to create a linked list. We want to create an array deck. And we want to create what else is there? Tree set. Now, if we just go hash set dog is equal to new hash set and put the list in it, or if we do add all, it's just going to create a hash set with the same 3 dogs, a linked list with the same 3 dogs, an array deck with the same 3 dogs, and a tree set with the same 3 dogs. We all understand that? Okay? So if we create a hash set from a list, create a linked list from a list, create an array deck from a list, create a tree set from a list, it's still going to be the same 3 dogs. Even though you have 5 different lists, there's still only 3 dogs in them. All right? That's shallow copying. What deep copying is, we are going to create a copy of those 3 dogs, but they're 3 different dogs. So we'll have 3 separate dogs in here. We'll have 3 separate dogs in here. We'll have 3 separate dogs in here. And we'll have 3 separate dogs in here. So you'll have 15 dogs. Now they'll all be the same, but there'll be 15 different dogs. You understand that? That is deep copying. Now it's not on the exam. All right, I don't know why, but sorry, kid. We did. Yeah, exactly. You should be sending back a deep copy. Okay. Now it's not covered in immutables, believe it or not. I don't know why it isn't. Okay. Maybe it's because it can get very complicated, but we're going to try and keep it simple. All right. What we're going to do is we're going to have a method that whatever variables we create the 3 dogs with, we're going to create 3 new dogs with the same variables. That's what we're going to do. Okay? There's a number of ways of doing it. Now, we'll do that at the start of the next section, which if we're lucky, it'll be someday next week. So you need to remind me that we need to do deep copy. All right? We need to do this. Okay? You need to know how to do this. It is important. Because imagine a situation, you think you have 15 dogs, you only have 3. You think you have 3 products. You think you have 15 products, you only have 3 products. All right? You could have many different types of lists. You think you have different items in each list. You don't. You only have 3 items. Okay? So, but that's not into the next section. So at the start of the next section, we're going to show you how to create deep copies. All right? Now, so now we're going to go on to the next one, which is actually we're finished. Jesus Christ. Okay? So I need to, so we will do that tomorrow again. So Zoom. Now I think I need to send, do I need to send an email every time to get them to log in? I probably do. I'd say, fuck. So I'll have an email all ready to go and I'll just send it to you tomorrow morning then when we're starting off. Okay? So, and I'll stop this so, and I will export the code.